I'm going to show you how to do Edexcel A-Level Maths June 2022, Paper 1, Question 16. My name is Sunil Tanner. I'm a tutor and author. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. Please like and subscribe. Okay, question 16. As you can see, it's quite a long question, so what I've done is we'll look at the whole question a little bit and then we will look at it over a couple of pages, where what I've done is taken each section of the question and put it on a separate page. So, okay, question 16. We have this graph here with a curve C and an area R filled in, figure 6. It says, figure 6 shows a sketch of a curve with parametric equations. X equals 8 sine squared t, y equals 2 sine 2t plus 3 sine t, and 0. T is between 0 and pi over 2, and you can see area R is bounded by the line x equals 4. The region R is shaded in figure 6, so it's bounded by C, the x-axis, and the line with equation x equals 4. And there's two parts of the question. First of all, show the area R is given by this integral, and second, find the area. So let's now have a look at it. I will do the same part A, but without the graph shown on the screen. So just need to remember that it's between 0 and 4 on the horizontal axis. Okay, so now let's look at part A. Show that the area R is given by this integral. Integral from 0 to A of 8 minus 8 cos 4t plus 48 sine squared t cos t dt, where A is a constant to be found. Okay, so if we think about a normal Cartesian equation, the area R would be given by the integral from 0 to 4 of y dx. Of course, all those parts of the integral are given in terms of y and x. So what we need to do is change them to be in terms of t. So first thing we do maybe is the limits of the integral. So we know that when x is equal to 0, we can use this equation for x to see what the t value would be. That would tell us 0 is equal to 8 sine squared of t. So that gives us sine t is equal to 0, so t is equal to 0. So t is equal to 0. What about when x is equal to 4? All right. When x is equal to 4, that would give us 4 is equal to 8 sine squared t. So dividing by 8, a half is sine squared of t. So that means sine t is 1 over root 2, and then if we do an inverse sine in radians, we will find that t is equal to pi over 4. So this now gives us the limits. What about y? Well, we've got an equation for y in terms of t, so that'll be an easy substitution. What about dx? We need to think about that. So we are given x is equal to 8 sine squared of t. So we can differentiate to find dx dt. So dx dt, now one way to think about this is to think about sine squared as being a product of sine t times sine t. So if you do that, you would differentiate the first sine t, leave the second one alone, which will give you cos t sine t, and you do the other way around. You differentiate the first sine t, leave the second sine t alone, which will give you cos t sine t. So overall that will give you 2 lots of sine t cos t times 8, so that will give you 16 sine t cos t. And here, if you multiply by dt, you can see that dx is equal to 16 sine t cos t dt. So now you can substitute everything into the equation here. I'm going to leave a little bit of space because we're going to have to do a little bit more work to... actually, we can just do it. Go ahead and do it. Yeah. So we'll say area is equal to the integral from 0 to pi over 4, and then the expression for y, which we were given in the question, is 2 sine of 2t plus 3 sine t times dx, which we know is the same as 16 sine t cos t dt. So we can probably see now that if we were to expand the brackets, we're definitely going to get this last term, 48 sine squared t cos t, but we're going to get something different at the beginning, so we're going to need to use trig identities to make the first part give us these first two terms of the expression here. Okay, so let's expand the brackets. So what we're going to get is integral from 0 to pi over 4 of 32 times sine 2t times 16 is times 2 is the 32, then sine t cos t plus 48 sine squared t cos t dt. So that's almost what we want. This first term we need to figure out how to make that into 8 minus 8 4 cos t. Okay, so here what we're going to do is first of all use the double angle formula on sine t cos t. Now you will remember that's that if you were to do that will be 8 sine of 2t, because using the double angle formula for cos. So this will be the same as that would be half, yeah, of the number here. So we'll halve the number. So this will give us a 16 sine squared. So yeah, so sine t cos t is the same as half sine of 2t. So we could do that. So let's write it like that. 32 sine 2t is the same as half sine of 2t. Yeah, and then we've still got the rest is the same, plus 48 sine squared t cos t, and then I guess all in brackets here. Yeah, so that's going to give us 16 here, right? So now we need to think about how we can change that into this expression here. So what we can do is we can think about what cos 2 theta, what could we do with cos 2 theta? So cos 2 theta will be the same as cos squared theta minus sine squared theta, using the again using the double angle formula. And sine squared cos squared theta is the same as 1 minus sine squared theta. So that would be cos 2 theta will be the same as 1 minus 2 sine squared theta. So if we rearrange that, we'll get 2 sine squared theta is the same as 1 minus cos 2 theta. So if we said theta is equal to 2t, that would tell us, for example, that this would tell us, for example, 16 sine squared of 2t is equal to 8 minus 8 cos of 4t. So using that, we can now tidy up this first expression. So just finishing off a bit. First of all, let's tidy up the 32 times a half and the sine 2t times sine 2t. So that will be pi over 4 here. We'll have 16 sine squared 2t plus 48, draw a line here so it doesn't interfere, sine squared t cos t dt. And then using this identity here, we will have pi over 4, and then we will have 8 minus 8 cos of 4t plus 48 sine squared t cos t, and then I guess I should have put the integral limits in properly. It's pi over 4 and 0. Yeah, sorry, it's a bit messy. And then dt here. So here a is equal to pi over 4. And that's everything we need to complete part A of the question. Okay, part B of the question is to do that integration. So again, I'll start a new page. Okay, actually we need a page with a bit more space. Hold on 1 second. Okay, so here we go. So now we want to do this integration. Okay, for part B of the question, 8 is obviously going to integrate to 8t. 8 cos 4t, if you think about it, it will integrate to 2 sine 4t, because if we differentiate 2 sine 4t, that would give us 8 cos 4t. The slightly tricky one is this last part, sine squared t cos t. Now we can probably figure that out because we can think about think about differentiating, for example, sine squared. So for example, if we did d by dx of sine squared t, yeah, that's going to give us, if we think about it as a product rule, it's sine t times sine t, so we would differentiate 1, which would give us cos t times sine t, do it the other way round, which will give us sine t times cos t, which will give us 2 sine t cos t. So what about if we did d by dx of sine cubed? So if we did d by dx of sine cubed t, we could think of it as being a sine squared t times a sine t. So if we differentiate sine squared t, that will give us 2 sine t cos t, and leave the other sine t alone, and now do it the other way round. We'd have the sine squared t, and then we differentiate the sine t part, which would give us cos t, so that would give us 3 sine squared t cos t. So now we can know what would happen if we differentiated 48 times of that. So d by dx of 48 sine cubed of t is the same as this, but you could have times it by 48, and what we would, we want 48 of these. So if we had 48 of these, we've gone from 3 to 48, we've times it by 16. So we would have to times this side by 16. So it would be 16 sine cubed t would differentiate to 48 sine squared t cos t, which is what we've got in the expression here. So the antiderivative of 48 sine squared t cos t is 16 sine cubed t. So now we can do the integration. So the area here is so 8 becomes 8t. This becomes minus 2 cos of 2 sine of 4t. And then this becomes 16 sine cubed, so let's put part B in here, sine cubed t. And the limits are 0 and pi over 4. So now all we need to do is to put those into the expression here. So we've got 8 times pi over 4, which is 2 pi. We've got 8 times 4 times 0 is 0, so 2 times sine of 0, which is 0, right? We've got sine of pi over 4 cubed, so that's actually going to be 1 over root 2 cubed and times 16. We can work it out on the calculator. It comes out as plus 4 root 2. Now I put in 0. 8 times 0 is 0. This will be 2 times sine of 0 is also 0. And 16 times sine of 0 cubed is also 0 as well. So this comes out to this. And then our final answer is 2 pi plus 4 square root of 2. And that completes the second part of the question.